This video is for the square roots foldable. So on the front of this, we're going to talk about what are square roots, evaluating square roots, and square roots on a number line. So the first part of this is vocabulary. So a square root of a number is a value that when multiplied by itself gives the number. A radical symbol indicates that the square root a number needs to be found, or that the square root of a number needs to be found. So this symbol right here is called a radical symbol. And what's underneath the radical symbol is called your radicand. So a square root, or a perfect square, is a number that can be represented in the shape of a square. When finding the square root of a perfect square, the result will be a natural number. So the first part here says to evaluate the following perfect squares. So in your calculator, to do a square root, you're going to hit second and then this x squared button, and that will make the radical symbol for you. And then you just type your number in, and we see that the square root of 16 is 4. So the next one, the square root of 144, gives us 12. And then the square root, so again, second, and then this x squared button of 36 gives us 6. And then finally, the square root of 81 gives us 9. And so these next ones are word problems. So these are word problems involving the area of a square, often indicate that a square root needs to be found. So number one says a square has an area of 64 feet. What is the length of one side of the square? So to find the area of a square, you would do the sides squared, and that's going to give you the area of a square. So to do the opposite of this, you square root it. So if we fill this formula in, so we know the area is 64, and we know the formula is the side squared. To get rid of this, exponent of 2, what we can do is we can square root, and let me grab a different colored pen here so you can see. We're going to square root both sides. So if we square root this side and we square root this side, the radical and that exponent of 2 cancel each other. So it ends up looking like this. The square root of 64 is going to equal the length of one side. And so if we do that, if we do the square root of 64, we get that the side length equals 8. So the next one says Jason is designing a square garden. He has enough fertilizer to cover 144 square feet. So again, this right here is indicating that's the area. What should be the length of each side of the garden? And we also know that it's a square. So again, we can use this same formula. So we know the area, and we know the area is going to equal the sides squared. So we can square root both sides. And remember, these two things cancel each other. So we're left with the square root of 144 equals the length of the side. So if we do the square root of 144, we get 12 again. All right, the next ones are on a number line. And so non-perfect squares, these are going to be irrational numbers, and we'll talk later more about irrational numbers. So it says evaluate the following square roots to the nearest tenth and plot the answer on a number line. So I'm going to zoom in a little bit so you can see these number lines a little bit better. So what we're going to do, we're going to find the square root of 2. And you can see on my number line here, it's to 1 decimal place. So we're going to round our answer to 2 decimal places. So if we round to the hundredths place, we look at the 4. The 4 says to stay the same. So our answer would be 1.41. So on the number line, it's going to be a little bit more than 1.4. And so we would put a dot there, and that would be the square root of 2. All right, so the next one is the square root of 24. So again, we're going to round to 2 decimal places. So we're going to look at the 8, and the 8 says go up. So the 9 goes up to a 10, and the 8 goes up to a 9. So our answer here would be 4.90. And so, but we know, I'm sorry, guys. We know that it's not quite at 4.9. So I'm going to put it really close, but not right on it. So that would be the square root of 24. So the next one says plot the following square roots on the number line below. So we're going to do the same thing here. So the square root of 67, if I round, I would get 8.19. And so what I'm going to do is I'm going to calculate all of these first. So the square root of 75 would give me 8.66. The square root of 82 would give me 9.06 because the 5 tells me to go up. And then finally, the square root of 90 would be 9.49. So now that I've calculated them all, I can get them all on this number line. So 8.19 is going to be in between 8.1 and 8.2. So I'm going to put it pretty close here to that 8.2 because it's real close. If we round it again, if we round to the tenths place, it would go up. So this would be the square root of 67. 8.66 is going to be in between 8.6 and 8.7 and almost exactly halfway. So this one would be the square root of 75. All right, 9.06 is going to be between 9 and 9.1. And again, almost exactly halfway. So that would be the square root of 82. And then 9.49 is going to be between 9.4 and 9.5. But the same with this one, it's closer to the 9.5. So I'm going to place my dot pretty close there, and that would be the square root of 90. So if you notice on our number line, as we increase, so does the radicand, the number under the radical. So that's it for this video.